Now let's play with the moving windows for time series data. So first let's play with time series data. Okay, in just previous lecture we have seen what is this various kind of time series data, like share market predictions, like heartbeat, like e-commerce sales, in a hour how much sales they are have in an hour, like that. In video format as well is a time series data. So they are have one very famous technique is the moving windows features technique. Okay, using this technique, how we will use some features, how we'll detect some features according to this window. So let's see it. So this is the most simplest featureization technique of the time series data. This is the simplest featureization technique. HTTP of the time series data. Most simplest one, this one is. Suppose let's take, I have taken some examples that ECG data. Let ECG data I have taken here. So the ECG data actually look like this type. This is the, if you consider this is a time axis and this is the frequency. This like this kind of data. So the first thing here that we have to do, first thing we have to take some windows frame. Suppose let's, I have taken some, consider it depends on the domain's expert, what will be the best window frame. Suppose that is a time axis, I am taking in frame like 1 second. Suppose let this frame is responsible for 1 second data. This interval is 1 second. Let actually it's depend on domain to domain. So this suppose let 1 second. So now based on this frame, we have to take some conclusions on this ECG data. So let's be specific for it. So it will be better for better understanding. Suppose let's, our job is first task is for such kind of data. So first we have to predict the heart attack in some next 10 minutes. That's the job. The job is we have to predict the heart attack in next 10 minutes. Okay. So first, what kind of features we will take into our considerations. So the first features may be based on the max mean of this frequency, of the frequency of this frame, max mean. First features may be like this kind of, means it depends on the problem to problem. Suppose let, means I'm talking about general purpose case and most simplest one. So based on this 1 second framework, based on this 1 second windows, consider the mix, what is the maximum value on this windows, what is the minimum value on this window, like that. There are various type of features on features too, just like that, means various technique they are have. So first, the from this thing, from this windows be, the first one is what first thing that we have to do. So let first thing we have to first decide what will be the windows width. Okay, first step that we have to taken for this stage. First step we have to decide the windows, what will be the size of the windows width. The second features, the second step is that we have to take, we have to consider, we have to consider that features that are useful on our taxes. Once on the basis of on the basis of the domain's expert knowledge, on the basis of our requirement, we have to specify our features that are actually useful for these taxes. We have to specify our features that are useful for our tasks. First, second step based on these features, we have to make our vector. We have to numerical vector. We have to make our numerical vector. These things actually called the features vector. Suppose let for these things I have considered f1 features, f2 features, f3 features, like that. Like that. Suppose let's I'm taking fm features here. So these things, the thing that's the vector that's called the xi. Now our job is for these things we have to predict the corresponding yi value. So this yi value will be hard attack in next 10 minutes or not. This yi value means this thing. In the next minute or not. So these things that are actually you have to do. So let's see is through a practical examples. So let's see it. Now let's try to understand this thing time series data through these examples. This data, these pictures I have taken from the Google image. Just search it on the heart attack datasets. You can easily find this kind of data. Okay. So just I am taken from the Google image. So just see it. So first thing what I have to do? First step is you have to select the windows width. What will be it? So first suppose let I have selected by some discussing some the domain expert means some doctors that are expert already in this field. We have selected some windows bit. Suppose let's I am considered here some windows bit on these regions like here. Like here, like this is our windows frame. Suppose let I have taken some windows frame, like this is our windows frame. Okay, some windows we are interested to take our decisions based on these windows. Suppose discussing something about the doctors, about some domain expert, we have selected these things. The first step that we have to do. So these are the time axis actually. These things, if you think this is the time axis, and this is the corresponding amplitude of the waves of our heart rate waves. This is the amplitude of it. So just first we have to take in how much second we have, how much time this windows frame have, and based on this time data we have to select some features, some best features of it. So this is the one best important area in signal processing area. If you are a guys of from electronics background, then already I think you will already learn, or applied mathematics background, then you will I think you will, learn about this subject, signal processing subject. Okay, so first thing that based on the medical expert decisions, we have to take the decisions how much windows bit will be better, how much time taken interval will be better to take these decisions. So the decisions have been taken by the simple medical expert. Medical expert. Okay, the first thing that we have to do. Now the second thing we have to consider based on this windows width. Based on this window we have to take some decisions on the base of this windows width. Means the features we have to select it, some features on the basis of it, based on this windows width. So first features I'm taking just most common one, most general one, that in general purpose we have used. The most common one is the mean, and based on the mean, what is the mean value of the and the standard deviation value. First most common one is mean and standard deviation. Okay, the most common one. The second one is the what will be the median or quantiles. Or quantiles, like that kind of features. Third one will be what will be the maximum range. So just see here it is the maximum, here it is the minimum value. So what is the maximum value and minimum value of this waves? Amplitude means max, min. These kind of features we have to take into our considerations. The third one is look like this. Third one. Fourth one is what is the difference between maximum and min value? So differences, it's what will be the differences between these two values, like that. Here it is the maximum value, here it is the low, means in these windows it is the maximum. What will be the difference between it, and what is the maximum, means normalized, after normalized these things, what will be the normalized value? This kind of thing actually I'm talking about. So the fifth kind, it will be like this. What will be the local maximum and local minimum, like that? Just see it here in this. Here it will be local somewhere here. Somewhere it will be local maximum, somewhere just little bit zoom it, then it will be just little bit zoom it, then it will be clearer. Just see it. Here somewhere local local maximum here, local minimum here, here somewhere here local maximum, here local maximum, here local maximum, here local global minimum, I think it is here somewhere here, like that. It's like that, this kind of, okay. Also this kind of thing, take this kind of things we have to take into our considerations, okay. So the local maximum, local minimum, like local maximum, local minimum, this kind of thing. Now the third thing is means mean value, mean crossover or zero crossover. It's another language you can call it. Zero crossover means that just see it. What will be the mean value? We can easily find it from the just age data set. Just take it from age data. Suppose like I've taken here. It's a vector quantity. It's a numerical quantity. It's numerical quantity. Numerical quantity, and such kind of quantity we will get from here to here in this frame range, in this frame data range. The vector quantity will be look like this here. So from this vector for each timestamp, for this vector, we can easily calculate it, its mean, what will be standard deviations, what will be its median, quantized, max, mean, like that kind of things easily you can find from these vector quantities. Okay, so the thing that the zeroth crossover means it is the mean line somewhere here, like let somewhere here, it's the mean line. So how much things it crosses, how much values, how much times it the rate, the amplitude value as crosses the mean crossover line. That's things are very important to detect the hard rate features. So the sixth most important one is the zeroth crossover line. Zeroth crossover line, this thing. Zeroth crossover means the mean crossover, how much time it's crossed the mean value, and how much time it's the somewhere this thing actually I'm talking about. These are the features, and just from these two pictures you can see it is the normal rhythms for a normal persons, and it is the aerial fibrillations, actually medical term. I am not aware about it. Just sit in, it is the normal paper heartbeat, and it is the for means just people those who are conditions to attack heart attack, okay. So these are the heartbeat on there, based on the, just see it, based on the time features, the same window, if you just apply onto this window, same time series also if you take it onto this frame, and if you just find the same features, that features we have built on the normal rhythms, and the same features if you build on that rhythm, so then you can find some kind of differences there have. So based on these things, for a normal and for this kind of data, you can conclude that you can build a models that can easily detect. Okay, these are the actually important thing that we have to know for build a features vectors for this kind of time series data. Okay, I think you got the point what I am on to say. So I think you got the point from these explanations. So the concept that the concept time series concept are mainly used in it's actually time series data is not a perfect always. It's depend on time to time and it depends on our environment. It's actually QoS type of data. So every time so we have to retrain our model based on the previous data. So it's not a one time effort. Means when we just want to get a output something, so at that time we have to retrain it again just from the just previous data. Since it's a time series data, its changes is huge dramatically. Okay, actually it's totally don't depend on a past events. It's depend on a just past event. So this thing, suppose let suppose this is a one kind of heartbeat data. Suppose now on this data we have to predict the heartbeat. First we have to consider the some Windows frame onto it. Suppose let's is the time for time t1, its Windows frame is this one. Now we have to predict the what will be the chance in time 2 t2. It is possible to get the heart attack or not. It is possible to think means just from this explanation you got the idea. Just what is the main differences for the normal people rhythm and the for then and the aerial fabrications type of thing. What are the difference from this? Based on these features you can take the decisions compared with it. Okay, so these things are mainly applicable on the deep learning. When we learn the deep learning concept, then we will see these things in details, how these things are applicable on this time series data. And when we discuss the case study, various case study, then also we will learn this concept. Deep learning. The main advantage of this deep learning mean here we have to manually choose these features. These kind of features we have to consider. But the main advantage of it is it's automatically detect what features we have to choose or not. It's automatically detect these things. Okay, so this is the main because of these reasons. Because of these reasons, the deep learning is so popular in today's world. Okay, so since it's automatically detect the features, which features are important and which are not. Okay, we will see it when we learn. So before just going to learn, we have to complete something like we have to complete the linear algebra part. Before that, linear algebra part we have to complete, and one thing we have to complete the multivariable calculus. Multivariable calculus. We have to complete these two things. Then after that we will come there. And before completing these two things, we have to learn some Python coding. So I think it will be better for better visualizations if we're doing the hands-on training onto it. So parallelly on theory and practical, if we doing these things parallelly, then I think it will be more visualizables. So these things after completed these three chapters, we are going to the deep learning chapter. And now and when we discuss the case studies on based on the deep learning, based on the supervised learning model, based on the unsupervised learning models, then it will be better for better understanding how this actually till now we have learned various kind of algorithms, but till now we have not seen how these things are actually applicable on the real world data. When we teach when we will done the case studies, various kind of case study, then we will see how these things are actually applicable on real world data.